Topic 7, dealing with compound interest, okay, comparing it to simple interest as well. Looking at the difference between the two, we're going to introduce it through an investigation. We're going to look at investing $1,000. Okay, I think you should all have $1,000 saved up by now. Investing it at 10% per annum for 5 years. Okay, we have one option, investing it at simple interest. The other option, investing it using compound interest. We want to see which one will give us the better outcome. Okay, the difference between simple interest and compound interest is, in simple interest, the interest is calculated just based on the initial deposit all the time. So in this scenario, the interest earned for the first year in here will be 10% of 1,000. Okay, $100 interest, and the amount at the end of the year will be 1,100. I'll copy that 1,100 down for the amount at the start of the second year, but the interest earned will be 100 again, because it's always just 10% of 1,000, which is the initial amount, and we can complete the table. Alternatively, compound interest, okay, sounds better, compound sounds good. In the first year, the interest will be the same. It'll be 10% of 1,000. End up with 1,100 down here. But in the second year, because the interest is calculated on the balance, in here we're going to be finding 10% of 1,100. So the interest earned for the second year will actually be $110. So at the end of the second year, in simple interest, we would have had $1,200, but in compound interest, we would have had $1,210. I want you to complete the rest of the table. Okay, hopefully you've completed that by yourself and you got the same as me, and neither of us made any mistakes. So you can see at the end of 5 years, using simple interest, we would have ended up with $1,500. But using compound interest, we would have ended up with $1,610. So we would have made an extra $110.51 just by choosing a compound interest account instead of a simple interest account. So when you're investing money, really important that you read the fine print and see whether you're getting simple interest or compound interest. That probably doesn't seem like much of a difference, but if we look at this scenario over 20 years, we only looked at the 5-year difference. Okay, this little difference in here of $110.51. Okay, as the years increase, okay, this red line is simple interest, and this green line is compound interest. And we can see how advantageous it is to be investing compound interest, reinvesting our interest each time. Okay, you'll see lots of YouTube videos talking to you about how good compound interest is and how you should use it to make money for you. Okay, so that's just introduction of what simple and compound interest are, a bit of a revision from last year. We should be able to create models. So linking it back to the previous lesson, should be able to create models for both simple interest and compound interest. So in simple interest, what happened was we started at 1,000 and we increased by 100 each period. Okay, so if I wanted to make a model for that, I'm thinking, is it linear or an exponential model? Hopefully you come up with the idea that it's linear. The gradient or the increase for each extra year would be positive 100, and the starting value was 1,000. So in this y equals mx plus c form, we would have y equals 100x plus 1,000. Realistically though, we should probably define our variables better and say let a be the amount, let t be the time, And we should be comfortable with a model that looks like this, with A's and T's instead of Y's and X's. Okay, really important that we define our variables. Yeah, that's a linear model. The one we're really focusing on is the compound interest. If we have a look back and look at what's happening, the amount we start with again is 1,000. How much is it increasing by each year? What we're really doing is increasing it by 10% each year. If I take some of these values, so if I took 1,000, what I started with, times it by 1.1, I'll get the amount at the end of the first year. Times it by 1.1 again, I'll get 2010. I should get these other values all the way through. If I go all the way to 20 years, I should get the 7,000. It'll be in here somewhere. That's 7,400 would be the 20-year one that we see at the end of this graph. Alright, so to create a model for it, alright, to create a model, okay, we're starting at 1,000 and increasing by 10% each year. Okay, when something's increasing by a fixed percentage each year, we know that it's going to be an exponential model. We have the form y equals k a to the power of x. In this scenario, this is telling me my k value is 1,000 and my a value is 0.1. No, that was on purpose. Okay, a equals 1.1 because we're increasing by 10% each year. A needs to be bigger than 1 and finding essentially 110%. So my model will be y equals 1,000 times 1.1 to the power of x. But again, we should define our variables better. Let a be the amount. Let t be the time. So my model should really be a equals 1,000 times 1.1 to the power t. Okay, just to check that these models work, let's see if we can get the amount after 5 years for both of these models using calculator. So for the linear model, I'll sub 5 in there. 100 times 5 plus 1,000. I get 1,500 like I should have. And for the exponential model, it'll be 1,000 times 1.1 power 5. Get $1610.51, exactly as I should. Okay, so compound interest is an exponential model, and we'll now look at the proper formula for compound interest that takes into account some other things, such as the number of compounding periods per year. Okay, so turn the page for the use of the formula. Okay, this formula you should put into a big box, okay, because it's really important. Basically, A is the amount that we have at the end of the time period, so after T years. P is the amount that we invest. I is the interest rate as a decimal. Okay, the compound interest rate per annum. K, the number of times the interest is calculated or compounded per year. In the example we looked at on the previous page, we compounded it on a yearly basis. We did the calculation at the end of every year, but we could do a calculation on a more frequent basis. Okay, for example, we could do the calculation daily, in which case K is 365. We could do it monthly, in which case K is 12. We could do it quarterly. So for all of these things, to find the K value, we're thinking how many of these things occur per year. How many quarters per year? 4 quarters per year. How many half years or 6-month periods per year? It's only 2. And how many years per year? It's just the 1. So we'll look at an example with k equals 1. Using the formula, calculate the amount that an investment of $100 will grow to at 10% compound, 20% compound interest invested for 5 years, compounding yearly. So I recommend that we always make this list of all of these variables that we could possibly be asked to find. Okay, I don't know the amount at the end. I know I'm investing $100 at 20%. So I'll write that as 0.2. It's compounding yearly. So from my table, k equals 1, and the time I'm doing it for is 5 years. Okay, make sure we write our formula down, and then substitute in the values that I know. So I don't know A, I know P, 1 plus 0.2 on 1 to the power 1 times 5. So I end up with being able to just basically mash this into my calculator. And I'll end up with $248.83 at the end of 5 years. That's basically how it works. Compound interest formula is exactly the same as that one we created before. This thing here is really 100 times 1.2 to the whatever, and the power is the number of years that's occurred. Okay, just to remember that we're not just pulling things out of thin air, we're just using the same drills. All right, we can change the frequency at which we calculate and add on the interest. In the first question, we just did it on a yearly basis. We want to see what happens if we do it instead on a monthly or daily basis. So if I changed it to compounding monthly, okay, I'm going to list the variables here exactly the same. Everything will be the same except the k value. Okay, the k value, how frequently I'm compounding the interest, how frequently I'm adding it on and reinvesting it. Since it's monthly, k will be 12. Okay, and I can write my formula. And substitute in all of these values. And see whether or not I actually earn more money if I'm calculating the interest more frequently. Doing my normal rounding, I end up with $269.60. So about an extra $21.23 just by doing the calculations more frequently. Then I can have a look at compounding daily using the same idea. Okay, listing all these things exactly the same. And hopefully we get the idea that as we increase the frequency at which we do these interest calculations, okay, the k value will get bigger. Okay, in this case, k will be, because it's daily, we're calculating it 365 times. And hopefully it's intuitive that the amount that we end up with at the end of the period will also be bigger. Let's see how it goes. By compounding daily, we've made another about $2.15 just by calculating it each day. Okay, and obviously a computer would do those calculations on a daily basis for us. As a challenge question, try and do the compounding every second. There's no reason why you can't do that. Just thinking about the k value, thinking of how many seconds there are in a year. Okay, from here, have a go at these exercise 8D questions. There's a few of them there, but they shouldn't take you any longer than it's taken me to do these questions individually. Make sure you have a go at them, because the next topic will be trying to find, say, P or I or T, which will be a lot harder if you're not familiar already with the just using the formula in a standard fashion. Okay, bye.